Every fine craftsman knows the value of a finely crafted tool, that the quality coming out of his shop is only as good as the equipment he's put into that shop, and that the moment he hits the switch on one of his Delta machines, he can expect precision, productivity, pleasure. For well over 60 years, Delta's been a permanent fixture in many of the finest shops anywhere. Yet today, Delta quality is still priced to fit nicely into your shop.
Funding for the American Woodshop provided by Delta International Machinery Corporation. For generations, Delta has been making a complete line of precision woodworking tools. Delta tools are available through local woodworking dealers, hardware stores, and home centers. Delta, building on tradition.
Hello, welcome to the American Woodshop. I'm Scott Phillips, and I've just made a model of the 1903 Wright Flyer. It's a remarkable piece of work. Most of it's made out of wood, and we'll learn more about how it was put together and designed when we go visit the Wright brothers' shop. When we come back from that visit, I want to show you how to make a boomerang. It's a pretty complicated flying machine in its own right. This is Carillon Historical Park in Dayton, Ohio. It's the home of many creative ideas, and these ideas have a course of history. We're here in a replica of Orville and Wilbur Wright's workshop. This shop was active from 1897 to 1900, and they had three businesses here. They had a printing business, a bicycle design and repair business that was very popular at the turn of the century, and this is where the first aviation industry started. It's remarkable to think they used a wood lathe and a drill press and hand tools to design the first heavier-than-air aircraft. Here's another innovation. They had to design their own engine to power the tools in the shop, and this was powered off of luminous gas, or natural gas as we call it today. They designed an engine like this with the help of Mr. Charlie Taylor. He was their chief machinist. And they used what they learned in building this engine to build the world's first successful aircraft engine. This engine powers a series of belts and pulleys that are hooked up to this line. It's called a line shaft. And that, in turn, powered their drill press and their wood lathe and a couple sanding tools that they had. It's remarkable to me that the Wright brothers were able to build and fly the Wright 3 Flyer using such simple tools. Now let's go visit with Mr. Wilkinson Wright. He's the grandnephew of Orville and Wilbur Wright, and he's going to show us how the Wright 3 Flyer actually flies and talk a little bit about how the Wright brothers came up with their ideas. Mr. Wright, it's a pleasure to be here with you today.
Nice to meet you, Scott.
This plane that you're the grandnephew of the Wright brothers.
That's right.
Okay. And this plane that they've built is a remarkable engineering feat. Could you tell us more about it?
Well, Orville described this as the world's first real airplane. That is, this was the first of the planes that they developed that could do everything that an airplane had to do. It could turn and bank and fly circles and figure eights, and more important than that, it could stay aloft for over half an hour. The pilot had to lie prone on the wing. His left hand held this lever, which operated the elevator, or out in front of the plane. With his right hand, he held this lever, which turned the rudder in the back, and you'll notice that his hips here are in a cradle-like arrangement, and this cradle operated what the Wrights called wing warping. This is the same principle that you have today in aileron control, but the Wrights rather than having ailerons or separate flaps, simply gave the whole biplane structure a helical twist, so that the trailing edges went down on one end and simultaneously went up on the other end, and that's the way they controlled the roll axis on the plane. These runners are, I'm sure, ash, probably.
Ah, okay. Because of the strength.
Because of its strength, yes, and its resiliency, as you know.
Right.
Ash is a very tough wood.
Okay. And then you mentioned the spars and the...
These spars were pine, and I think they were selected because of their light weight. Excuse me, this is a strut. The struts are of pine. There are two main spars that go the length of these wings, and they were of spruce. And then the ribs here in the wing were made out of formed ash. They were put in a jig and shaped and then nailed and glued so that they kept a permanent curve or camber, the amount of camber that they wanted on those wings. And these were, again, ash that had been bent. So on their powered planes, the ribs were formed out of two pieces of ash with little wood spacers every so often, and they were put in a jig and nailed and glued so that they came out with the curvature that they wanted. The earlier gliders had simply bent ash ribs, but with only in one piece. And the problem was with those, of course, is that the more they used them, they tended to flatten out with the pressure of the wind and wear. But these were sufficiently rigid to hold the camber that they wanted while they were in the air.
And of course, the reason for the curved wing is to provide more lift. A straight wing doesn't provide as much lift.
Finally, Wilbur, in what I think was a very brilliant piece of reasoning, finally decided that a propeller was simply a rotating wing foil, if you will. So then they went back to the data from their wind tunnel experiments and designed their propellers on that basis. Now this is made out of two pieces of spruce laminated, and then they literally carved it out with a hatchet and a draw knife.
Mr. Wright, did they actually build this plane themselves?
Every bit of it, almost. They had some of the parts of the engine cast, of course. They bought heavy chains to run the propellers and so on. But most of the work they did themselves. I mean, they were the carpenters, they were the mechanics. They did all this wire rigging and so on. All of that was done by the two brothers.
Remarkable. And when they originally designed the plane, I guess they did it because they were curious about it, and they did it because they loved it.
They wanted to try gliding as a sport.
Amazing.
and look where it's taken us.
Oh boy, isn't that the truth? Well, thank you very much, Mr. Wright.
My
This has
pleasure,
been great.
Scott.
Mr. Wright, certainly a wealth of knowledge. I really enjoyed the visit. By the way, if you'd like to learn more about the Wright brothers, this book by Orville, How We Invented the Airplane, is excellent. Now it's time to make our own flying machine. Boomerangs. They've been around for over 11,000 years. And look on these back sides. Here's a secret to a boomerang, these back bevels. I'll show you how to make those, and these leading edge bevels as well. Think of a boomerang as a flying wing. Here's one wing and here's another. They have to be tapered in a certain way to fly right. To make a boomerang, you need a saw, a good wood file, some sandpaper, and a good pattern and some imagination. Boomerangs come in all shapes and sizes. This is a cross-stick boomerang, just two flat pieces of wood 12 inches long and 1.5 inches wide with beveled edges, and they're glued together in the middle, and it flies really well. And yes, boomerangs do come back to you, and I'll prove that when I go out to show you how to throw the boomerang. Now think of a boomerang as not only a wing, but a propeller as well. And the way you shape it, here you can see that this is a bell-shaped boomerang, and these are my favorite shapes. They give the most interesting flights. Has all sorts of different profiles on them in order to give you the lift of a wing and also the spin of a propeller. Really doesn't matter what size they come in, all the same aerodynamic forces apply. After making boomerangs for years, this is the best flying one. And as you begin to make boomerangs, whenever you have one that works right, take good care of it and use that as your master to make other boomerangs. A good source to come up with original patterns is at your local library. Just take it to a copy machine and enlarge that pattern, and that will be a good start for you. Now here we're going to use plywood that has 5 layers of veneer that have been glued and sandwiched together. So we're ready to go ahead and get our plywood ready. This is double stick tape, and I'm just going to put several panels together at one time. That way I can go ahead and make several boomerangs at the same time. And we'll put this on the bottom here. And that double stick tape will hold the plywood together so that I'll actually get 3 boomerangs for every one that I cut out. As I mentioned earlier, this bell-shaped boomerang is my favorite design because when it flies, it'll stay in the air for up to 15 seconds and cover at least 200 feet in its flight. I've laid out the patterns, and you can see that I have 3 pieces taped together. Always put the double stick tape under pressure with clamps or weights to make sure it bonds firmly. Now we need to make sure that this guide block assembly is as close to the workpiece as possible without having the 2 touch. Lock that into place. Always make that adjustment with the power off. We're ready to make our cuts. I like to use hearing protectors, and I'm also going to use my safety glasses, as always with any power tool, but this time I'll use a face shield. I'm using a blade that has 6 teeth per inch, and it's a 1/4 inch wide, and I'm using a dust collector. Cut on the outside edge of the line. That way you'll be able to sand to the line and maintain the full shape of the boomerang. I'm going to slow down my rate of speed, and I'm also going to cradle this piece so that it doesn't gouge out my pattern. That does it. Now I have 3 patterns for the work of 1. Time to make them fly. So first, separate the workpiece from the double stick tape. That's good. Make sure the double stick tape is off the bottom there. Lay your blank on top of a flat surface. You can see that this tip curves up slightly, and that's good, and that's marked the top. If it wasn't curved, we'd use a candle flame to heat the bottom and curve it up. That's one of the secrets of a boomerang. In fact, not many people realize that. This is my favorite boomerang, and I've made this after years of practice, and you can see that it has a very steeply tapered trailing edge. It really helps to envision how the boomerang's thrown. You'd hold it like that with the curved edge. You can see that this is curved, that's flat. The curved edge in your hand facing you. And so as we'd throw it, we'd whip it like that, and the leading edge is at a 45-degree bevel, and the trailing edge is at a 30-degree bevel, all the way from the center line of the boomerang here to the center of that tip there. That's a 30-degree bevel, and that will be a 45-degree bevel. And this is reversed on the other wing. Instead of having this trailing edge here, think about how the boomerang flies. As it spins through the air, this will become the leading edge. So that's at a 45-degree bevel, and then the trailing edge is at a 30-degree bevel. And you can look on the back side and see that I've gone ahead and tapered the tips in a way that's very similar to that wing warp that the Wright brothers used. Because think of this, look at this tip. It's warped and sanded so that that curve meets this back edge and comes forward at about a 5-degree bevel. And then as it would rotate around, there's another curve here that's cut the same way. So as it flies through the air, it actually starts to force the wing to the left. So here's how we go ahead and start this. We're going to sand a 45-degree bevel around the entire edge of this workpiece. And here's the top. I'm using a dust collector, but it's always a good idea to use a dust mask as well. And it's just a matter of taking your time. And there was a rough spot. Work it down. And you can see why it's important to leave your line of the pattern on the boomerang. That way, as you sand it down, you end up with a full-size boomerang. That's good. And you repeat this process until you have the entire outside edge beveled at a 45-degree angle. Another tip is to keep the boomerang moving as you're sanding it so you don't create any dips or valleys in the edge. I'm using 100 grit sandpaper here. That's coarse enough to take off a lot of stock at one time, yet it still produces a nice smooth edge. Take a close look at this. You can see that there's a bevel about 45-degree angle all the way around the edge of this boomerang. Over here, if you bring it back to my original boomerang, and this is the one I'm using as my master, you can tell that this is the one that I'm going to need to taper back and feather it at about a 30-degree angle. And this edge over here on this wing will need to be tapered at about a 30-degree angle as well. Okay, and those lines just help me to keep everything straight. Again, look at that profile there and this profile. Because this edge is the leading edge and that edge is the leading edge, the only thing I have to do to finish preparing these edges is round this bottom edge over so that it creates a nice smooth bull nose. And start by working it to the line that you penciled in. Remember, that line wasn't precisely marked out. What I'm looking for is just a nice, smooth, continuous bevel that's about a 30-degree angle. It doesn't have to be precisely 30 degrees, just as long as it's balanced on each edge. Slightly steeper angle now that I have my edge beveled down fairly well. Okay, the trailing edge is done there, the trailing edge is done there. Next, you never want any sharp edges anywhere on a boomerang. So you go ahead and take all the edges down so that they're nice and smooth around the entire periphery of the boomerang. Now, here's the secret. Most often question asked is, does that thing really fly? Well, yes, it flies. Well, does it come back to you? Well, sometimes. It depends on the wind, but it also depends on this secret. On the bottom of any good boomerang, you'll see an area that's tapered here at the tip and down here. And what that does, as the boomerang flies through the air, it creates an airfoil that wedges the boomerang and spins it to the left. So it completes a complete circle and comes back to you. Without these bevels on the bottom, that boomerang doesn't have a very good chance of coming back to you. So what I'm going to do is roughly sketch in the bottom bevels off of my master here. And it's very important to make these bevels so that it's about a 5-degree taper, starting here and then coming back to this edge level. We'll do that on both these tips.
I'll round that slightly. And then that feels really good and smooth. And just to make it look a little bit better, I'll take one more cut. That's good. Okay. Now that these are finished, just go ahead and give the entire surface a light sanding. Very light, because you do not want to change any of the profiles that you've sanded into this boomerang. Keep it moving so you don't create any grooves. Very good. Well, that looks great. I'm happy with these profiles, but they're a little bit rough in a couple places. So I'll go ahead and use 100 grit sandpaper to hand sand those radiuses nice and smooth. And that almost is finished and ready to take a good polyurethane finish, something that will hold up to the rigors of moisture. Okay. But before I go ahead and put a finish on it, and that's completed now, has all the profiles on it that I need, it's back to this flat surface to check the warp. What I want is to have the tips raised up so that they're about 1/8 to 1/4 inch above the flat of this plane as the back of this elbow is pressed flat to your surface. And to do that, the best thing is to use a candle. And that heat from the flame reactivates those heat-cured glues that were used to make this plywood in the first place. And you just come back about 4 inches from the end, and you keep it moving so that you don't burn the bottom of the boomerang. And you'd be surprised at how well this works. Really flexes those tips up. It's starting to come up now. And really, no one that I've talked to uses this technique. And I think that it's the difference between a good boomerang and a great boomerang. Okay, that's looking good. And if you do scorch it a bit, you can sand that off. But the key is don't burn it. Okay, that's perfect. I'll do the same to the other side. And that's going to take a couple more coats before it's ready to fly. But we'll go ahead and do those. And then we're going to head out and I'll show you the true secret of the boomerang, throwing to the wind direction. Here we are in front of the United States Air Force Museum. And not only is this the world's oldest collection of military aircraft, but it's also the world's largest. It's well worth spending a day here if you're in the Dayton area. Now, to fly the boomerang, it's a lot of fun and it's really easy, but there are a couple steps you need to follow. We turned this into a wing by rounding over the top with a convex shape, and the bottom's flat. So to hold it for a right-handed throw, you point the curved part towards you, the flat faces your hand. As you angle the boomerang out, the V faces the horizon. The most important thing is that you work with the wind. You face the wind and then throw the boomerang at about a 50-degree angle or at 2 o'clock to the wind. That's the most important tip. Okay, for the throw, all you have to do is throw it like a baseball. It's an overarm throw and follow through. Okay, and as you release it, you want to snap it so that it imparts a spin into the boomerang. That provides a lot of the lift, just like a propeller. So now I'm working with the wind. I'm going to throw it at about 2 o'clock to the wind. And as I throw it, the boomerang blade will be perpendicular to the ground. Sometimes on windless days, you can can it out at about a 10 to 15 degree angle. That'll help it to come back. So here's how it works. And keep your eye on it during the flight. That way you won't get hit by it and you stand a better chance of catching it. And catch it with both hands. Now, with the different wind and different boomerangs, you'll have to adjust your throw. But again, all you have to do is follow through and whip it, kind of like a tennis smash. Follow through, that gives it good spin. We're here on Huffman Prairie, and this is the site of the world's first airfield. In 1904, the Wright brothers perfected flight here with their Wright 3 flyer. The flyer was quite a remarkable feat, and it was made mostly out of wood and quite a few unique engineering ideas. I can't help but wonder if the Wright brothers had any idea of how far we'd come in such a short period of time. Yeah! Oh! Oh, okay. I'm trying. The wind has to cooperate a bit. But if you do it right, which I didn't do, and have fun.
Funding for the American Woodshop provided by Delta International Machinery Corporation. For generations, Delta has been making a complete line of precision woodworking tools. Delta tools are available through local woodworking dealers, hardware stores, and home centers. Delta, building on tradition.